All right, so welcome to the lunchtime video. This is a really good schedule of work for me yesterday, so hopefully I can keep this going. I start work at 8 a.m. now. I started a little earlier in coronavirus world B, so I'm going to be doing a lunchtime video 12 to 1, and then an after work video from 5 to 6. So that's 2 hours of studying in a day. I think that'll be plenty. So this morning I rebooted my lab, so hopefully it's all ready to go. So I'm sharing my screen, and I am sharing screen. Oh, so I paused it for some reason. I'm going to do a new share just to make sure I'm. Okay. Yeah, I was just sharing the application, so now I'm sharing my entire screen too. So you can see my lab here. I'll bring up the agenda for the lunchtime video today, and it's going to be continuing on with the topic we were in before. Which is IGP. Okay, so yep, so now we're going to be learning about address issues. So this hopefully will be pretty easy. So hopefully I can get through both address issues and routing loops in one video, or maybe just get through both of those topics in one day would be enough of a progress. Okay, so let's go into this for address issues, create the classic notes file. Okay, and now create the actual notes, and we'll think about what tags are appropriate to include. All right, so it's not going to be MTU issues for this one. It's going to be address issues. Okay. So, and then, yep, these are all the tags that are going to be there for every single one. I think even Linux is going to be there for every single one because VMX rides on top of FreeBSD, which is a Linux distribution. So definitely going to have IGPs, definitely going to have troubleshooting. Definitely these two. I think I'm also going to include IPv6 in this video. Then we'll look at issues with IPv6 addresses as well as IPv4 addresses. All right, so let's pull up the lab and let's do just our basic heuristic for how to get started. Using help apropos. So this one is attempting to use radius, so it's got that big pause there. I could disable it, radius. Why don't I just do that so I don't have to deal with that pause? So, yep. Let's just delete the radius server. I don't even have it set up on the Linux anymore, on the guest one. And then I don't have to deal with that pause. All right. So, yep, should be a lot faster now. Okay. So let's take a look at that show run again. Okay, so it looks like all we've got on here are IP addresses for our IPv6. So let's pin up some IPv4 addresses as well. One thing we can do, instead of just deleting all the config, is we can deactivate it and just look at one set of configuration at a time. But yeah, so I think that that's a better way to go. So let's do a run showing description. All right, so let's set up an IPv4 address. So we'll just use the, okay, and let's start with network 1, so we don't need to think about network 0. Okay, so we'll set up a bunch of /30s. Okay, and I don't think it's necessary to worry about the Linux guests host quite yet. We're just going to be learning about VMX Juniper devices, so there's no need to think about those other ones. Okay, but let's go across the links and set up the .2 addresses. So the first one's going to be on router 2. Okay, and it's going to be the link to router 1, which is GE001. Oh, and we got support assist. Support assist is ruining my day, and it's my birthday too. Thanks, support assist. All right. So let's see here. I'm going to install support assist. Actually, that bothered me enough to install it or do something. Let's see here, support assist. Ah, here we go. Uninstall. Sweet. Sweet, I uninstalled it, so it won't be bothering me anymore. So let's set up the other side of this. Perfect. Okay, and let's essentially use like an algorithm, just mental algorithm, just a method to do this where we branch off each one. So we're starting on the one here. So we're going to see each one to its completion. So this is going to be, oh, we're going to need address. But this is going to be only complete after we configure the other ones. So this is 0. So let's go with the next one. So we've got, oops. So yeah, we got networks 1, 2, and 3. So the next network is going to be network 4. Okay, and then network 5. Okay, so now let's use that same strategy from before, where we go across the link. So we're going to go across the link to router 3 now. All right. Oops, and I was able to change the tab, it looks like somehow. I can only do that unintentionally. If I could do that intentionally, it would be a game changer for me, but unfortunately at this time I can only do it unintentionally in cases where I wish that it had not changed, instead of intentionally in cases where I did want it to change. All right. Okay, so now we've got GE000 to router 1. So we already know what that is going to be. It's going to be the one going to router 3, which is this one. So it's going to be .3.2. All right, so now this one going to router 4 is going to get a new address. It's going to be a .1. So it's going to be .6. Okay, and then the one going to .2 already has an address, so it's going to be a .2. And let's figure out which one it needs. So it's the one going to router 3, 000, so .4. Okay, so now let's do this same strategy where we just go down and configure the other side. So we already configured the other side for router 1. We already configured the other side to router 2. So we just got one more other side to configure, and that's to router 4. On this one, we're going to go back and do the other ones. Okay, so to router 3, so it's going to be .6.2. And then .5.2. All right, and then we've got one more to go, and that's to router 1. So it's going to be .2.2. It looks like I accidentally configured this on 2 interfaces, but it only belongs on 000, not 002. Oh, and we got the same problem here. We've got an identical interface. So this one does belong on 000, so let's see on what other interface it is configured. Oops, and it changed tabs without me intending it for it to do so. Which is interesting that it can do that. I wish it would do that with me intending it to do so. Okay, but it does belong on 00. It doesn't belong on 002. All right, so we got one more to go. Oh, so we've got the same issue here. So this belongs on 000, so let's see whatever other one it's on. Oh, it's also on 2, so let's get rid of that. Okay, so let's try to ping across the links on all of these. Oops, but it looks like we've got 001 on here. I wanted 011. So let's fix that up. Ah, family INET. That's interesting. Oh, /30. There we go. All right. And I'll be back in just a minute. I gotta throw my gum away. All right, I'm back. So let's test all of these. Perfect. Perfect. All right, so we can, yeah, let's just test them on every single router just because it's not efficient, it's not fast, but it guarantees that the result will be accurate for all of them. So the least efficient thing you can do, of course, is make mistakes. And I can see there's already mistakes, so let's do a delete. All right, so that looks a lot better to me. Let's see if I can ping across the links on all of these. Oops, so we got an issue here already. So let's just T-shoot that right away. Okay, so to router 3. So let's see which port goes to router 2 and router 3. Okay, so let's take a look at what's on there. So we accidentally put .4 on there instead of what was intended to go on there, which is, this is 000. Just do a show configuration. Oh, so we've got .3 and .4 on there. So it looks like .4 is the intended one. And this one's listed first, so it's the primary, which is why that ping wasn't successful. So let's just delete this. Okay, so that looks a lot better. Hopefully the pings will work. Okay, so we got an issue with GE002. And that's going to router 4. So let's take a look at which port on router 4. Yeah, so it looks like this failed. We've got identical addresses. So we know that it is meant to go on the one to router 2. So this statement is correct here. Let's see what the incorrect statement is. So it's going to be this one is incorrect. Oh my God. Okay, so that statement is now corrected. So hopefully this pings, and it does. So we've got all 3 pings. 1, 2, 3. All right, it's time for router 3. Oops, so it looks like it's shifted over when I hit enter. That's all I hit. I only hit enter and it shifted over. So I think on my way to figuring out how to shift over the tabs. I did it. So if I click it and I hit enter. So if I double click, so if I click this once, click it again, and hit enter, I can shift the tab over to router 1. Let's see what happens if I do it on router 2, router 3. Okay, so if I click the tabs twice, but I can't double click them because that makes it expand. So I've got to click it once and click it again, making sure I don't click it too quick, and then hit enter. And then that skips it over to the first tab. So I'm not sure what the intention is behind that behavior. It really, like if you have to click on the tab, I don't see any reason why you couldn't just click on the first tab. Like, why would you need 3 strokes, click, click, enter, especially when 2 of those strokes are time dependent, they can't be too close together. To do something you could just simply accomplish by clicking the tab you wanted. So on the test, I'm going to have secure CRT, which I am used to using. At my previous job, at my current job, they're not going to buy secure CRT licenses for everyone. So I'm using Terminator. I figured out a way to set it up on the Windows subsystem for Linux. But Terminator, unfortunately, is a little bit lacking for me because you can't just do a real easy Control-A, Control-C, and copy everything in the shell. I also can't find a way to do scrollbacks, but it's not too bad to just highlight a section, use the slider bar, and then hit, so you would highlight the end of what you wanted, hold down Shift, click. Oh, so it doesn't work in here, but it does work in Terminator. You just highlight the start of what you want, you scroll down to the end of what you want, you hold down Shift, and then you click, and then it'll highlight everything. And you can do take it off the terminal into a notepad that way. It's not too bad. It does have a Control F, but it's the highlighting is all wrong on it. So it's not perfect, but it's better than this solar putty or just putty alone. Secure CRT is my preferred, but you need licensing for it. All right, so let's see here. So we were verifying the addresses. Oops, so there's an issue with this one. Let's take a look at what this connects to. Okay, so it connects to .3, but here I have configured .1, which is not correct. So let's take a look at the configuration. Maybe it's configured on there twice for some reason. It is. So let's get rid of the extra statement. And again, just to kind of drive home the point, we weren't able to ping, which might seem odd because we do have the correct address on there. But this address is listed first, so it's the primary address. So fortunately, we can't, there's no mechanism to fail over to the secondary if the primary doesn't work. What we can do on this side, so you can see when there is a packet coming in, it can dynamically choose what is the appropriate address to receive it on. But when there's a packet coming out, or going out rather, it's right. Because I do have a direct route for that. But if there's a packet, right, okay. So there's no .1 on the other side of the link is what's going on. It's not because it's a primary or secondary address that it cannot ping 10.0.10.1. It's because the other side of this link, which is router 1 GE000. So let's take a look at, 002 is the other side of this link on router 1. It's because that does not have that address on it, is why it can't ping. It has nothing to do with it being a secondary or a primary address. All right, but let's get rid of that erroneous address. And I believe it was, yep, it's the .1. All right, so let's try this again. Perfect. So everything's good to go on router 3. We got one router left, router 4. Oops, so I did the thing where I clicked it twice. I only clicked it once, but it seems like sometimes you can do that even though you've only clicked it once. But I can definitely do it every time if I click twice. Oops, except for now it doesn't work. It only works if you click it once to switch to it, click it again, and then hit enter. If you click it twice, so if you enter in input, and then you click it, okay, but then you only have to click it once. Okay, so yeah, really strange feature. I'm not sure what they were intending that to optimize, but this terminal, I'm kind of a believer that so it's thinking is the bottleneck. So it's really not about what tools you use, what automations you use. It's not about how fast you can go. It's about, can you have a stream of thought that is strong, uninterrupted, and that can lead to a outcome or result that you want. That determines whether or not something is going successfully, not how fast you're typing, not what tools you're using, not the rate at which you work. It's really the quality and level of your thinking. That's what's going to slow you down instead of anything else. Yeah, thinking is the bottleneck, not necessarily speed. So yes, I could go faster if I used a different terminal. It could help me think, yes, but it's not a huge issue. A really good example of how thinking can be a bottleneck is if you've got too many notifications enabled and you're constantly getting your phone's ringing, your work laptop's ringing, everything is just ringing and you can't think anymore. That's going to be a huge bottleneck for you, much more of a bottleneck than using Solar Putty instead of Secure CRT or some other better terminal. But I do have those disabled for the most part, so I really don't have a huge thinking bottleneck right now. So let's continue to work. Okay, so everything's all set up for router 4. So we already got practice with having incorrect addressing. I'm not exactly sure what they mean when they say to troubleshoot that. So configure and troubleshoot. But obviously we did get a lot of really good practice with address issues. The other kind of address issue we might need practice with is an ISO address issue for ISIS. And I believe I have ISIS already set up. Yep, so ISIS is already set up. So let's play around with this ISO address and see if we can get some issues. So on router 2, or on one of the routers, how about router 2? Let's do, oops. Let's enable the trace options for ISIS. Okay, so we're good to go. Let's do the monitor start. All right, so we're going to see a lot of extra chatter just because I'm doing the flag all. Let's actually do a monitor stop and see if there's better things to look for. Okay, so here we've got things that might be better. So let's narrow it down and not do a all. So let's do a delete on this. Okay, and now let's do a set. Okay, and let's do packets. Let's do hello. Oops. Okay, let's do packets, and then in another statement, let's do hello. And in another statement, let's do route. Okay, and now let's see what other options there are, because we're going to be looking for address issues. So let's do error as well. Okay, and I think that'll be enough to shoot address issues. And remember, this is going to be ISO address issues, not IP address. Okay, so yeah, that looks good. Now let's do a monitor start again. Okay, so this looks a lot more manageable now. We see we've got the hello packets coming up. We've got the LSPs coming up. We've got much more useful information now. Okay, so let's switch around those addresses, and instead of using an extended NET, let's just use a regular NET, and then let's give it a different identifier. So let's take a look at what's currently on there. Okay, so this is an extended NET. We're going to have an extra section that belongs to the area. I'm not sure why they need that. Like it just seems like a lot of areas. But let's take this out and then create a new one. Okay, and we'll have them all be in area 0. But of course, that's something we can play around with having different as well. And then for the unique identifier for this device within this ISIS topology, we'll just do all zeros and a 1. So it's going to look a lot more simple of an NET. So now it will be at odds though with the, well, actually it won't be. Well, it might, because, well, let's figure out if what's its, is it going to be compatible? Is it going to be able to form a neighborship? Let's figure all this out right now. Let's just do a monitor stop. It looks like it is working actually, because it is installing everything. Let's do a monitor stop and look through it. So it was able to build a level 1 unicast table. Oops, so we've got an address not matching. I don't see any errors though. I think error messages have error appended to the message, the word ERROR all in caps. Saw that in a previous video. So one thing we can see is the local area is going to be different. So, so Aha, designated router mismatch. So that's good to know. And there we go. ISIS area mismatch and ISIS rejected adjacency. And this is because we've got an area mismatch. We've also got a designated router mismatch. So lots of problems when you have addressing issues for the ISO NET address. But it looks like the good news is that it's pretty darn clear. It is calling out an RFC, so let's take a look at that. RFC 4444. And let's add that RFC to the notes. Okay, and take a look at the RFC because it looks like it's relevant for ISO addressing issues, which is what this topic is, address issues. So if it's IGP address issues and ISIS is an IGP that's going to be on the test, the addresses that may have issues will be ISO addresses as well as IP addresses. This memo defines a portion of the Management Information Base, MIB, for use with network management protocols in the Internet community. Specifically, this document describes a MIB, Management Information Base, for the intermediate system to intermediate system, ISIS, routing protocol when it is used to construct routing tables for IP networks. So this is really just about, this RFC is just saying what can be gleaned from SNMP polls to MIBs, management information bases. It's really just defining what you can get when you do that. So you can get system-wide attributes, ISIS system, ISIS. So I think we got this. Let's just go back and take a look. So we got, so let's look up these specifically. We won't have to read this whole thing. There's just too much information there. Let's just see if there's any useful information about this. Let's read the description. A notification sent when we receive a hello PDU from an IS, intermediate system, that does not, PDU I believe is protocol data unit for ISIS as well. Let's just look that one up quick because I know it does stand for protocol data unit in certain contexts, but yeah, okay, it does stand for protocol data unit within the context of ISIS as well as the context of a OSI model data. The context of data being described with the OSI model. They're just, you know, layer 1 PDUs through layer 7 PDUs. Whereas, yeah. All right, so a notification sent when we receive a hello PDU, protocol data unit, from an IS, an intermediate system, that does not share any area address. This notification includes the header of the packet, which may help a network manager identify the source of the confusion. The agent must throttle the generation of consecutive ISIS area mismatch notifications so that there is at least a 5-second gap between notifications of this type. When notifications are throttled, they are dropped, not queued for sending at a future time. Okay, so that was interesting. Let's read the next one. a notification sent when we receive a hello PDU from an IS, but do not establish an adjacency for some reason. The agent must throttle the generation of consecutive ISAS reject adjacency notifications. So just like the other one, this says the same thing that it said up there. They're just going to be happening so quickly that if you didn't throttle them, you would be overloading all your buffers. So there's an artificial 5-second gap inserted between those notifications. And if you don't do that, you're going to have problems. That's all that's saying. All right. So, oh, we got about 11 minutes here. So let's fix this up on router 2, and before we commit, we'll start that monitor again. So edit family inet. Oh, I did family inet. I've got to do family ISO. So this is router 2, so we'll give it a .2. Character not on. Oh, I forgot a 0. So this is a good one to know because that will trip me up on the test if I've never seen that before. I'll probably be checking everything but what I just typed. And if I just checked what I just typed, I'd see, oh yeah, I forgot a 0. Oh, before we commit this though, let's do a run monitor start tshoot ISIS and commit and quit. Okay, let's do a monitor stop because I think everything is good here. Oh, actually, let's not, because we are getting those RFC 444 messages still. But now I think we're going to be fine. So let's do a monitor stop and look over all these messages. So let's go back to, okay, so here's our RFC 444. So we actually will still be getting these for the other neighbors, but the neighborship between router 1 and router 2 will be fine. So if I do a show ISAS adjacency, we're going to see a level 1 and a level 2 adjacency between router 1 and router 2, but between router 1 and router 3 and router 4. So that's going to be 4 adjacencies total that would be up normally if there weren't a ISO addressing issue. Those are either going to be down or they're not going to be established. I have a feeling that for level 1, they will be down, but for level 2, they will, actually, I think they'll be fine for level 2. The only problem might be that for router 3 and router 4, we've got extended NET addresses. We've got that extra 4 characters in the area that we don't have in router 2. So let's take a look. So yeah, it looks like I was correct that there won't be any issues for a level 2 connection between router 1 and oops. So it looks like I was actually incorrect because there is an issue between router 1 and router 4. I'm kind of surprised that there's no issue between router 3. So I'm not sure what's going on there. But you can see there is certainly no level 1 adjacency, which makes sense because they're in different areas. Oh, I might have the ports still disabled. Let's check that. Oh, oh yeah, I do. So that's why it's having trouble there, because I have it disabled. Oh, sorry, I have level 2 disabled. So, aha, so yeah, but this does make sense though. I don't have an adjacency to router 4 at all, because I won't have an adjacency on level 1. I'll only have one on level 2, but level 2 is disabled on router 4 for an ISIS adjacency to router 1. So I can't have a level 1 because they're in different areas, but I also can't have a level 2 because I disabled it. So I just can't have any adjacency at all. So let's remove this and let's see the level 2 adjacency come up. Ah, and it did that instantly. I didn't even need to give it a few seconds. So yeah, there's, as I predicted, there are going to be no issues with level 2 adjacencies because they're in different areas, and that's the point of a level 2 adjacency, so you can form adjacencies across areas. But there won't be level 1 adjacencies possible because they are level 1 adjacencies are for intra-area adjacencies only. They are not for inter-area adjacencies. Those are level 2 adjacencies. Okay, but let's jump over to router 3 and change the NET address on that, and we can get router 2 monitoring. Just do a monitor stop just in case, and then the monitor starts. Okay, and now let's change the NET on router 3. Oh, yes, and we will still be getting those because there are in fact mismatches on router 2 for the adjacencies going to router 3 and router 4. Those won't completely go away until we have finished those extra NET changes. Oops, and let's do a display set relative. Okay, so I think we're still going to have those RFC 444 messages coming up, but they're going to be far less frequent now that they only apply to one connection. All right, and I think we'll see another adjacency come up because router 1 will now have the ability to form a level 1 adjacency with router 3. So it looks like I've got an extra 16 in there still. Not sure where that's coming from. Yeah, where's that extra 16? That's interesting. So we do have, it looks like a MAC address to go off of. And it looks like the leading zeros have been taken out. So let's just try adding those in. There we go. So we do have a match, but I unfortunately don't. Yep, I can't do a pre-lines or anything like that. So I'm not sure which one it matches. What I can do is show. Yeah, because I'm sure it matches the one going to router 1. So I can do a show ints 0 and then pipe match on that, and then I'll know if it matches there. Oops, but of course I'll need to do it without that abbreviation rule applied. There we go. So yep, it's this one, and the issue is that it's getting a different NET address for some reason. Oops, and I'm out of time right now. So, but we can, nope. So, okay, well, let's take one last look at interface L000. So this is perfect. This is a really bizarre out there issue. Perfect. If I see this on the test, I'll know exactly what to do. So stay tuned in the next video where we finish up this topic, and then hopefully we can move on to the next one and finish that one up too. So stay tuned, and thanks for watching.